here we go. I'm going to record if we have enough time to do something here. So how about if we start with a frequency? Or we could start with an energy. How about what is the wavelength of a photon that is, let's just make up a number, 2.69 times 10 to the minus 18 joules of a photon that has that much energy. Let me move this over. Energy per photon. So this one's kind of going backwards. So we have E is equal to H nu, and C is equal to lambda nu. Let me try it. Okay, and so what I can do with this one, we used this one before. If I rearrange this equation, frequency is equal to C over lambda, then I can substitute that in for this one here, right? If that's true, then E is equal to HC over lambda, because C over lambda is equal to nu, right? Does that make sense? Okay. So what I'm going to do is let's take this expression and let's rearrange it to solve for lambda. What's lambda equal to? If E is equal to HC over lambda, let's isolate lambda in the numerator. Anybody? No? So here, I'll start working.
E over HC?
Yeah, or it would be HC over E actually, because I want to get lambda on the top, right? And I want to divide by E on both sides. Yeah, and then that cancels and that cancels. So we get lambda is equal to HC divided by E. So now I can plug those in. So H is a constant, C is a constant, and I was given the energy of a photon. So let's plug those in. Planck's constant is 6.626 times 10 to the minus 34 joules times seconds. The speed of light is 3.00 times 10 to the 8 meters per second. And then let's divide by energy of that photon, which we said one photon was 2.69 times 10 to the minus 18 joules. Okay, what happens to the units here? Someone said S cancels. Yep. Anything else? Someone said joules. Okay, and joules cancel. So what I'm left with is meters. And that's what I wanted. Yeah. And then it's just calculator. So should I bring the calculator in again? Okay. So let's see how does I do this right? Okay. So that's kind of glary. Like that. Okay. Clear. All right. So 6.626 second 10 to the minus 34 enter times 3 second 10 to the 8 enter. Okay, and then I'm going to take that answer and divide by parentheses 2.69 second 10 to the minus 18 close parentheses for the exponent, close parentheses for the all that stuff in the bottom, and there we are. So that's the wavelength. So that is 7.389. Actually, we should have 3 sig figs, right? and then times 10 to the minus 8 meters, right? And then what we could do is actually we could go back to nanometers, right? There are 10 to the minus 9 meters in 1 nanometer. So that just becomes, well, the wavelength would become 73.9 nanometers. So that would be like far ultraviolet bordering on X-ray, right? So that's the, should we go forward again? Do another one going forward?
How
We
did
could
you
start
get
with
the 7.389 times 10 to the negative 8? Because mine didn't show that on the calculator. Can I see the calculator again?
you want me to calculate it again?
No. Just you could just leave it like that.
Oh.
Yeah. Okay, that's fine.
Okay. Well, this is the setup. Make sure that you can do this at home, I guess is the point, right? So, and that you get that answer.
Yeah, I didn't. I got a e to the negative 44.
Okay, so what you didn't do is you got to put this in parenthesis. So what it did, if you don't put this in parenthesis, it takes this 10 to the minus 18 and puts it up top here. And so 10 to the minus 18 times 10 to the minus 34 would be 10 to the minus 52 times 10 to the minus 8. I'm sorry, 10 to the plus 8 would be it would be about 10 to the minus 44. You see what I mean? So it's really important here. Put a little star if you have to, that you have to use a parenthesis for the denominator. So that's really critical. So I mean, so we're off by 10, instead of being off by 10 to the minus 18, you're off by a factor of like 10 to the 36 by having it on the top instead of on the bottom, right? So just be careful, I guess. All right, let's do another one. We have time. Let's do another one. So how about let's take 1020 nanometer light, and let's do the same thing I did last time. Find the frequency and energy. Okay, so I'm going to take, so again, I'm going to convert it to meters. And so this one's about 10 to the 3. So what's 10 to the 3 times 10 to the minus 9? Anybody? No?
10 to the
10 to the 3
6?
times 10 to the minus 9.
Negative 10 to the negative
Minus
6.
6.
10 to the minus 6. Okay, so let's call this 1.02 times 10 to the minus 6 meters. Yeah? Okay, so that's the first step. The next step is find, so this was unit conversion. Let's find the frequency. So, 10 minutes, we'll make it. I'm gonna make it. Okay, so the frequency nu is equal to c divided by lambda, which will be equal to 3.00 times 10 to the 8 meters per second divided by 1.02 times 10 to the minus 6. So let's see. I'll do that in my, put this one in parentheses, right? So and this one is meters, right? So the meters cancel with the meters, and you get per seconds as
It should be 2.94 times 10 to the 14.
Yes, that's correct. 2.94 times 10 to the positive 14 per seconds. Okay, so that's the frequency. Let's find the energy is equal to h nu is equal to 6.626 times 10 to the minus 34 joules times seconds times 2.94. I'm going to use the unrounded value in my calculator, but 2.94 times 10 to the 14 per seconds. And so again, seconds will cancel with per seconds, and I'll get joules. So I'm just going to take that answer times 6.626 second 10 to the minus 34. And I'm going to get 1.9 to 3 sig figs, 1.95 times 10 to the minus 19 joules. And then again, we could take that and we could find that in kilojoules per mole if we wanted to. 1.95 times 10 to the minus 19 joules per photon times 6.022 times 10 to the 23 photons per 1 mole of photons times 1 kilojoule over 1,000 joules. So I'm going to take the number I had before, this one, the unrounded value, times Avogadro's number, 6.022 second 10 to the 23, and then divide by 1,000. And I get, this is equal to 3 sig figs would be 117 kilojoules per mole of photons. Okay, so that's it. I'm going to stop the recording there, and